హలో
ఫోన్ చేయి మరి ఎప్పుడు వస్తావు ఇంటికి?
హలో హలో తరుణ్ రవి
సార్
తరుణ్ కొంచెం యాడ్ చేస్తావా ప్రజెంటర్ యాక్సెస్?
చేశాను సార్.
ఓకే, యాడ్ చేసి నాకు చెప్పు, నేను క్లాస్ స్టార్ట్ చేస్తాను.
ఓకే సార్.
ఇవాళ నన్ను తిట్టింట్లే ఎందుకంటే
సార్ స్టార్ట్ చేయండి సార్. అందరికి ఒక 2 times ఇన్విటేషన్ ఇచ్చిండే.
ఓకే ఓకే సరే సరే.
तरुण पावनी ऐड नको. వచ్చింది. ఓకే.
Okay, now we'll start. will start. Can you able to see my live board?
Yes, sir.
Okay. Now we will discuss about the propulsion system. Okay, morning we have discussed the energy system for airspace vehicles, which are rocket propellants, and others are high energy chemicals, high energy liquid chemicals for the manned aircraft. Then the next topic, this is fundamentals of propulsion system. Have you ever wondered why rocket will just fly at a high speed or at a high altitude? Okay, the major responsible criteria behind this flying of rocket is a specific impulse, which is created by some specific propellants, which we charge into the rocket combustion system. Okay, now in this figure you can see that the propulsion system or the propellant system is at rest at P1, T1 and H1. What does that mean? These variables. P1 means a pressure when the rocket propulsion is at rest, and T1 is the temperature of that propulsion system when it is rest, and H1 is the enthalpy, U1 is the velocity. Okay, when these propulsion system is at rest, the velocity we can consider as 0. Okay, how this variables P, T, H, U can change when the rocket propulsion system has just been started. When this the propellant inside the rocket just combusted, the gases, heavy amount of gases, huge amount of gases which evolved from this combustion chamber will just eject through the nozzle which is present here. You can see the curved portions. This is the nozzle. The fluid velocity will just increases at a nearly to a speed of light, okay, which is small c. Okay, every variable here, the p1, t1, h1, u1 is just present as rest. Whatever is there, every variable will get changed in the position 2. Okay, this is regarding the positions and variables of a rocket during the from the initial stage to the final stage. Now, what is the specific impulse? How this specific impulse of a particular fuel is evaluated? Based on what criteria the specific impulse will be created in a propellant system? We have to see it. So I will share my live board. Okay, now see. If you consider this as a rocket system, so initially we are at U1 and finally we are at U2. Okay, the signal is not properly, so live work, just bear with me. So this is U1 and then next one is U2. Then have you ever wondered with reference to a simple example, I will try to say this one. For example, one person is standing at point 1, and he is about to go to the point 2 on the line. Here line you can see he is just crossing this line. He is standing at this point at rest, first point, and then he is going towards the point 2, okay, which is on other side of the line. So how to measure how much distance he traveled? How to measure it? We will just measure how many kilometers or the how many meters he just traveled, okay, which is also here in the same example in the rocket system, which is also same. Initially rocket is at rest. Okay, this is at point 1, or according to this variable this is at point 2. Okay, here also same we will consider point 1, simply the difference between the notation scheme only, nothing more than that. So see, consider this is point 2 and this is point 1. The person has to reach from point 2 to point 1, whereas rocket is also same. The rocket has to reach from initial point 2 to final point 1. So how much distance this has traveled is nothing but the measurement of distance that particular rocket or this particular person has been traveled, which is denoted by S. Okay, which is S means distance traveled by that particular rocket or a particular person. Then what about the velocity? Now we have to measure. This person already has been traveled from point 2 to point 1, and rocket also traveled from point 1 to point 2 to point 1. But at what speed this person or a rocket has been traveled, we have to measure that one also, because we have to gauge how much time it will take to reach the person from point 2 to point 1 is also one of the criteria in order to select how much the energy is required, even for the rocket also, for the person also. So this is the clear example. Now in order to measure this distance, we already measured the distance, but we have to measure a velocity or a speed at which this person has been traveled, or a speed at which this particular rocket has been traveled. So that speed, how to calculate that speed? That speed is nothing but velocity, or a speed u is given as change in that distance with respect to time. Okay, for a particular period of time, how much distance he is just traveling. For example, this is a discrete variable, then see s2 minus s1 divided by t2 minus t1. If this is a discrete variable, if he is at constant, then we can write this formula. Otherwise, we have to differentiate it. At each point of time, he is changing his speed, means we have to differentiate. Otherwise, his speed is constant, means we can write delta s by delta t, which is nothing but this formula. Okay, now distance is measured with s. Distance is equal to s, whereas velocity or the speed at which the particular rocket has been traveling is nothing but change in distance with respect to change in time. So this may considered as equation 1. And whenever a constant force acts on a massive body, okay, since this is a massive body, even the human body, or even a rocket, which is considered as a massive body, nothing but some mass, it is containing some mass. Whenever a constant force acts on a massive body, it causes it to accelerate. Okay, this is from Newton's second law of motion. What Newton's second law of motion is saying, whenever a constant force is acting on a massive body, it will tend to accelerate. So how to calculate that acceleration? Acceleration is denoted by small a, which is nothing but change in velocity with respect to time. This is called acceleration. Okay, acceleration. When this acceleration will cause, whenever a constant force is acting on some body, then this acceleration will cause. This is equation 2. Then according to Newton's second law of motion, what it is saying regarding force, Newton's second law. Newton's second law is saying force is equal to mass times the acceleration. Okay, force is equal to mass times the acceleration. In order to compensate for the gravitation, so we will write gravitational constant gc in the denominator. This may consider as equation 3. Already these equations already you might have known during the school days only. The first equation is, first variable is distance. To measure the velocity at which that particular rocket has been traveled, we have to define the first variable, which is velocity. U is equal to ds by dt. And second, whenever the mass is having a continuous force, whenever a continuous force is acting on some massive body, then that will create some acceleration. So second variable we are defining as acceleration. A is equal to du by dt. Then from Newton's second law of motion, we can say force is equal to mass times the acceleration. In order to compensate for the gravitation, so we need to incorporate in the denominator gc, gravitational constant. Okay, gravitational constant whose units may be kg meter per kg force second square. Okay, then so from Newton's second law of motion, we already defined F is equal to ma. So what is a? A we already defined from equation 2. From equation 2 we can write A is equal to change in velocity with respect to change in time. Okay, then mass. uh, Mass is a constant variable. Okay, mass cannot change with respect to location, whereas weight can change with respect to location, because acceleration due to gravity will act upon it. You might have known difference between mass and acceleration, mass and weight. Weight will change, whereas mass is constant. Okay, with respect to position. Okay, dm by du. So just we are putting inside the differentiation d dmu by dt. So we can consider, we already considered, this is equation 3, force is equal to m into a. Now we can consider this force equation 4 and this derivative as 5. Now velocity, we are calculating the velocity for a specific rocket from one point to another point. There are no discrete points here. Okay, we are not calculating point 1 or point 2.1, point 2.2, 2.3. We are not calculating like that. 2 to 1. Only at a single point we are calculating. From traveling from second point to first point we are calculating. Therefore, this cannot be viewed as a discrete one. Therefore, we can change the velocity at a definite point, which is f is equal to change in velocity into change in mass of system, mass of rocket or mass of the person with respect to time. Okay, we can do this as equation 6, I guess. Yes, 6. Okay, equation 6 this is. Now since this is not a definite variable, so we can define the point of change is u2 to u1. Velocity is changing from u2 to u1, so it is multiplied by dm by dt. Now we already defined our rocket initial variables here in the PPT. I'm just showing the PPT. Here you can see initially the solid propellant, the mass inside the rocket is just at rest. So velocity we can consider u1 is equal to 0 compared to the velocity which is creating afterwards after burning in a combustion chamber. So we can consider u1 is equal to 0, citing our variables in the reaction. So we may consider u1 is equal to 0. Now we can define u1 is equal to 0, u2 is equal to some velocity of sound c, small c, which is a universal notation for velocity of sound. Okay, which is defined as velocity of sound. Just we will substitute that there in the previous equation. F is equal to, in place of u2 minus u1, we will substitute just c, and in order to compensate the gravitational constant, gc will be incorporated, and the left out variable is dm by dt. Remember, in all this equation there is a gc. I forgot to incorporate in this one. Gc is already there, gravitational constant. So here also Gc is there. F is equal to Gc. Since here already we defined F is equal to Ma by Gc. Here also Ma by Gc, Ma by Gc, and Gc we need to incorporate. Now this is the equation which we obtained. Then just the next operation is multiply and divide by, multiply and divide with acceleration due to gravity, g and g. Okay, this is acceleration due to gravity, whereas gc is gravitational constant. Okay, the difference between both two may be noted. Gc is a gravitational constant, whereas g is a acceleration due to gravity. So our equation, this equation we need to just multiply and divide with small g. F is equal to c by gc is already there. We have to just multiply and divide with small g, and change in mass with respect to time is there already. So we can say Now see this. Okay, this G by GC along with this M. Okay, mass to weight conversion. Okay, we already added a gravitational constant is already there. In order to compensate, we just given a acceleration due to gravity to it. So we can write our equation F is equal to C by G is already there. This G, okay, M into G by GC we can write it's just a weight. So weight, mass to weight conversion. Okay, I already noted the difference between the mass. The mass of the object can change. Okay, the weight of the object can change with respect to location, but cannot, mass cannot change. Okay, with respect to location. Okay, this is the difference between mass and weight. Now we can consider this equation. Yes, 7. We can give this equation as equation number 7. Okay, now one specific impulse which is denoted by ISP is defined here. Okay, some author he has defined the specific impulse is saying which is the ratio of velocity of slide divided by gravity, acceleration due to gravity. From our equation 7 we can see here, from our equation 7 is this one, F is equal to C by G dW by dt. Okay, this is nothing but ISP according to the definition of specific impulse. So we can write from equation 7, we can write ISP is equal to U by G from the definition, and from the equation 7 we can write F by dW by dt. Okay, this is our specific impulse equation. By the definition, specific impulse is nothing but a ratio between velocity of sound and acceleration due to gravity. And from the equation 7 we can write specific impulse is nothing but a force or a thrust which is produced, kg of thrust which is produced with kg of propellant weight per unit time. Okay, dW by dt, where dW by dt is known as burning rate. Burning rate. Okay, where dW by dt is known as burning rate. I think it is clear. By the definition, ISP or the specific impulse is nothing but velocity of sound, ratio of velocity sound with and acceleration due to gravity. From the equation 7, ISP is nothing but this one. So we just send this dW by dt to the left hand side. Then ISP is equal to F by dW by dt. So specific impulse is nothing but a kg of thrust. Thrust here is nothing but a F, force. Kg of force or kg of thrust which is produced by burning a specific amount of propellant in the specific amount of time, specific time. Okay. Okay, I am writing clearly here. ISP is equal to F by dW by dt, which is nothing but kg of thrust means kg force. Force units in terms of kg is kgf. So mass units in terms of kg is kgm. So time units is second or hours, whichever applicable there. So kg of thrust which is produced by burning kg mass of a propellant per unit time. Nothing but the definition of specific impulse. Okay, now we have to see the how the rocket will just fly. Okay, change in velocity from u2 to u1 it is changing. So velocity is changing means nothing but a kinetic energy. Because of change in the kinetic energy only, the unit, the particular mass has been changing from one velocity region to another velocity region. Okay, otherwise it is not possible. Without a kinetic energy, it cannot be possible. So kinetic energy, change in kinetic energy, Ke we can write. Change in kinetic energy is already defined as half mu square. from the schooling days, we can remember this equation. Delta change in kinetic energy is equal to half mass into velocity square. Okay, then here the change in enthalpy is nothing but a heat. H is equal to U plus PV. Okay, PV work, it is due to PV work, and in terms of addition of internal energy which already the material contains, and due to the some work, PV bar work, we usually define this is PV bar work. Okay, due to these two changes, the change observed is nothing but an enthalpy change, which is given as H is equal to U plus PV from the thermodynamics. Now change in enthalpy, how we can write? H is equal to change is happening from point 2 enthalpy 2 to point 1 enthalpy 1. This is the change happening. We can write this as a delta H also. Okay, just we can denote as per our convenience. So now we can write delta Ke, kinetic energy, change in kinetic energy, is equal to half me square, we already written. So half into m into Gc. For the gravitational constant, we need to incorporate the gravitational constant v square. Since it is changing from location u2 to u1, so u2 square minus u1 square this is. So in order to compensate for the equivalent of since the rocket propellant, when it is burning, it is nothing but a mechanical energy. So in order to compensate for the heat from the mechanical energy to heat, we need to add some variable J. Okay, frequently this type of variables is encountered by the mechanical people. So J is equal to mechanical equivalent of heat, which is nearly 425 kg force meter per kilocalories, which is given as 425 kg force meter per kilocalorie. Okay, now we can define the variable H dash or enthalpy at a specific location with respect to our variable system, which is a mechanical equivalent H divided by G by Gc into mass of the particular propellant. This is the enthalpy definition with respect to our heat quantities, whereas previous one is with respect to mechanical quantities. Therefore, now we can write H dash is equal to, is already H. Okay, here see H is there. In place of this H, we have to substitute this one. Okay, we have to substitute this one. So that is nothing but m into u2 square minus u1 square divided by 2j Gc. This is for H, and the left out terms are G by Gc into M. So here see we can cancel out M. Here Gc we can cancel out, and we already known from the rocket propulsion U1 is already constant because fuel or a rocket is at rest. Okay, only U2 is there. U2 we already defined. U2 is equal to velocity of sound, small c. So the left out terms will be now H dash is equal to c square by 2j g. You can see this is c, 2j, j is there, and g is there, 2j g. Now according to from this equation we can write c square is equal to h dash by 2j g. Similarly, now what c will look like? C is equal to root of h dash by 2jg, h of 2jg. Okay, this is C. Then if we consider the enthalpy change is nothing but delta H dash is nothing but H1 dash minus H2 dash. Okay, this is the enthalpy change. So we need to write that formula in terms of these quantities. Therefore, we already know C is equal to H dash by 2jgc. So C by G is equal to, using the formula, C by G is nothing but ISP. So finally we will get ISP is equal to root of 2jg H1 dash minus H2 dash. Okay. As per the exam point of view, this derivation they are not asking, only for to know what are the quantities involved in flying the rockets. I'm just explaining it. You need not to worry this. Just I am quickly revising it. So in order to travel any body, any massive body from one point to other point, here the points we are just indicating 2.2 and this is 0.1. For traveling from point 2 to point 1, we need certain thrust. Okay, thrust is nothing but a force. Okay, so first we have to estimate the distance which has been traveled, distance which has between point 2 and point 1, which is denoted by small s. Okay, which is nothing but a distance. Now we have to calculate at what speed, at what velocity this massive body is just traveling. So velocity is nothing but change in distance with change in time. So if this is a discrete variable, we have to differentiate it. If it is a definite variable, we have to just define between 2 points, which is delta s by delta t. Then next one is we have to evaluate a velocity which is given as equation 1. Whenever a mass constant force is acting on a massive body, then it will create some acceleration in the body. That acceleration is given as small a is equal to du by dt, change in velocity with respect to time. And from Newton's second law of motion, it is stating force is nothing but a mass times the acceleration. Okay, in order to compensate the gravitational constant, we are incorporating ma by gc. Now, from the definition of acceleration, which is a, acceleration is nothing but du by dt. So we are substituting from equation 2, we are substituting du by dt here in place of acceleration a. After the series of transformations, we will get u2 minus u1, because velocity is a definite variable. Here particularly we are assuming it is moving from point 1 to point 2, location 2 to location 1, which is moving. So u2 minus u1 dm by dt. From the initial assumptions that rocket is rest, so there is no combustion in the rocket fuel or a propellant, so rocket is present at rest. So we will consider u2 is u1 is equal to 0. So u2 we are considering, u2 is equal to velocity of sound we are considering. So u2 is equal to c and u1 is already constant, citing our initial rates. So now we can write f is equal to, in place of u2 minus u1, u1 is already 0. So in place of u2 we are writing c by gc, c we are writing, already left out terms are gc into dm by dt. Then this equation we need to multiply with gravitation, acceleration due to gravity, g by g. Just to that equation we just multiply this one. So in order to convert the mass to weight conversion, okay, g by gc into dm is nothing but here we can write that g by gc into dm is equal to dw. Okay, because of this rule we are just writing here dw by dt in place of that gravitational constant. So according to the definition of impulse, we are writing ISP is equal to velocity of sound divided by acceleration due to gravity. So from equation 7, uh, F is equal to C by G dW by dt. So according to the definition of ISP, which is impulse, specific impulse, C by G is equal to ISP. So we are just transforming RHS side to the LHS side, we are just sending. So dW by dt will transfer to the left hand side. So here ISP is equal to U by G already by definition. From equation 7 we can write F by dW by dt. The meaning of specific impulse is nothing but the kg of thrust, okay, kg force or kg of thrust or kg of force which results from burning the unit quantity or kg of propellant per unit time, okay, dW by dt. The dW by dt is already also known as a burning rate. Okay, so this is the specific impulse, we can define that one. Then kinetic energy change. So in order to change a velocity, here velocity is changing. Velocity is changing, changing means it is nothing but a change in kinetic energy. So whenever the height is changing, there must be some potential energy. Potential energy is nothing but with respect to height changing, altitude changing, whereas kinetic energy is nothing but change in velocities. So from the school days we know that delta Ke or a change in kinetic energy is nothing but half mu square. Using the same formula, we just define the change in enthalpy is equal to H2 minus H1, whereas kinetic energy is, we are just delta Ke is equal to m into u square minus u1 u2 square minus u1 square by gc is for gravitational constant, and this j is for compensating the mechanical energy to heat transformation. Okay, in terms of heat quantities we can write enthalpy dash h dash is equal to h by g by gc into m. So that formula we substitute here, all the quantities like gc and gc and m and m will be cancelled out, citing the initial condition that u2 u1 is equal to 0, and left out terms are only u2, 2 and g and g. These are the left out terms we are sending here. So from the change in enthalpy, so c square, from this equation we will get c square, we are just sending this to that side. C square is equal to this quantity h by 2jc. So we are sending the square to that side, this square to that side. So we are getting the root on the right hand side. So root of h by 2jc. Then the change in enthalpy we already defined. Change in enthalpy means initial position minus final position, h1 minus h2. Initially the fuel is at rest and it is not burning, not at all burning. So enthalpy, the energy which already contained in that specific material will be high. So this will be positive. Okay, this will be quantity very high. H1 will be very high. Whereas when the burning has been started or burning has taken place from the long back, then H2 will be very low. The enthalpy will change, enthalpy will decrease, and it will give in the form of heat outside. Okay, so specific impulse is nothing but C by Gc. Using that same formula, we just calculated ISP is equal to 2J by G H1 dash minus H2 dash. Okay, this is the formulas. First one, this is according to your rocket propulsion. ICP is equal to C by G. Specific impulse is equal to velocity of sound divided by acceleration due to gravity, which is always equal to thrust per unit weight per unit time. This is the important formula. Okay, enthalpies and etc. you can neglect it, but remember this is the formula which is frequently asked, which is frequently being asked. Okay. Yeah, I hope you understood this one. As stated here, what is specific impulse? We already seen the specific impulse derivation. Specific impulse is nothing but a change in velocities, but initially we assume that u1 is constant. So we can consider velocity of sound. It is the ratio of velocity of sound per acceleration due to gravity, which is already always equal to the thrust created by that by burning the unit weight of propellant per unit time. Okay, F divided by dW by dt, where dW by dt is always known as burning rate. Okay, amount of propellant burned per unit time is known as burning rate. So specific impulse is nothing but from this definition, kgs of thrust obtained by burning kg of propellant per second or per unit time we can say. So it is nothing but a ratio of velocity to acceleration due to gravity as defined here, C by G. So it is the measure of effectiveness of a material as an energy source. Then, for example, initially when rocket has been started from the ground, how can we assume that this rocket will reach the orbit, some other orbital within this time or within this second, whether that fuel is enough in order to reach there? It is nothing but a mileage. We can say in our general sense, it is nothing but a mileage, specific impulse. It is calculated for only propellants. Okay. The next topic is the classification of energy systems. Okay, energy systems we already defined initially in the introduction only. So energy systems are nothing but high energy chemicals which will give a extremely large amount of energy with the explosion of gases. Okay, by burning it weight to time basis, dW by dt. This is called dW by dt, the chemical reactions and systems which release extremely large amount of energy on a weight time basis are called explosives and propellant. So energy systems are nothing but these two are the energy systems for space vehicles, and high energy chemicals for like hydrogen and boranes are also considered as a energy systems. Okay, these energy systems, how many types we just need to classify. So there are the 5 different types of energy systems out there. As you can see, the first one is the chemical energy system, and next one is the nuclear fission system, and third one is the free radical system, arc jet system, fourth one arc jet system, and magneto hydrodynamic plasma system. The below is their specific impulses. So from this specific impulse definition, we can directly say that specific impulse, the the fuel which has a high specific impulse is the very much advantageous for our rocket as a rocket fuels. But the high specific impulse is contained only for the magnetohydrodynamic plasma. But these four types of energy systems, like nuclear fission system, free radical system, arc jet system, and magnetohydrodynamic plasma, are underdeveloped. Okay, and they are developing. It is initially it is still in the R&D sessions. Okay, it is still not been developed. Okay, whereas chemical systems are more advanced systems. They already developed many different systems, like many propellants. Okay, high energy chemicals, hybrid propellants, solid liquid propellants, mono bipropellants. These are all very highly developed. This comes under chemical energy system, which have a specific impulse of 200 to 500. Now, large number of rockets are operated using this chemical energy system, whereas nuclear energy system, or a nuclear fission reaction system, which will have a specific impulse high compared to the chemical energy system, whose specific impulse is between 500 to 1500. Okay, this is also in a R&D, still in a R&D region, whereas history says that there is one rocket which has been manufactured using a nuclear power plant incorporated into inside it, but we don't know the status of that one, but it is under developing condition. And free radical system, it is not at all started, but estimated specific impulse of this free radical system is between 1500 to 2000. And next one is the arc jet system, whose specific impulse is between 1000 and 5000. It is also in a underdeveloped stage. And next one is magnetohydrodynamic plasma, whose specific impulse is between 30,000 to 60,000 seconds. Specific impulse is usually measured in seconds. Okay, 30,000 to 60,000 seconds it is coming. Therefore, these four energy systems, namely nuclear fission system, free radicals, arc jet, and magnetohydrodynamic plasma, these are underdeveloped system, and they are in R&D uh, development stage. Now, chemical systems are the more advanced systems. So we will just, according to your syllabus, we have only chemical energy systems. So now the below classification is for the chemical energy systems. So based on the reactant characteristics, these chemical systems are categorized. Chemical reactant system. These energy systems are classified into two types: mono and bipropellants. Okay, and based on the physical characteristics, these chemical energy systems are classified into three types. First one is solid, then like liquid, and hybrid. Hybrid is the combination of two or more propellant systems. Okay, further this solid propellant systems has been classified into double base system and composite systems. And further, this liquid propellant system has been classified into hypergolic and non-hypergolic. Now hope this classification you understood. First one is the classification of energy systems. Okay, how many types of energy systems are there? You may ask by this question. So first, for the first question is energy system. Classify energy systems. There are 5 types of energy systems. First one is the chemical energy system, which has a specific impulse of 200 to 500 seconds, and nuclear fission energy system, which has a specific impulse of 500 to 1500 seconds. Free radical system, which has a specific impulse between 1500 to 2000 seconds. Arc jet system, which has a specific impulse between 1000 to 5000 seconds, and magneto-hydrodynamic plasma, which has a specific impulse between 30,000 to 60,000 seconds. Whereas these the last four energy systems, from nuclear fission to magneto-hydrodynamic plasma, they are all in the underdeveloped stage, and they are in the developmental stage, R&D stage only. So chemical energy systems are largely developed, and further these chemical energy systems has been classified into various types based on the chemical reactant characteristics, whether it is reacting it monopolistically, it is reacting, or with some other propellant it is reacting. So the first classification is based on the chemical reactant system. There are 2 types of propellants which are under this classification, which are monopropellant and bipropellant. Whereas based on the physical characteristics, we classify this propellant system into 3 types. The first one is solid, the second one liquid, and third one is hybrid system. Further, the solid propellant system has been classified into 2 types, double base and composite. Further, based on the ignition characteristics of the specific propellant system, this liquid system has been classified into hypergolic and non-hypergolic system. Then now we will see in detail what are the monopropellant system. Monopropellant systems are nothing but a single chemical compound or a homogeneous mixture of compounds. Okay, mono means it's a mixture of homogeneous compounds, or maybe it is single component. Okay, each of which is capable of sustaining an exothermic reactions when catalyzed. Nothing but when we just initiate a reaction with them, each of which can use a exothermic reaction. All the energy systems which are existing now, we are talking about nothing but a exothermic reactions only. Only the exothermic reaction is having a capability of producing a large amount of heat together with evaluation of huge amount of gases. Okay, then bipropellants are nothing but which consists of an oxidizer and reducer. Okay, here oxidizer means like oxygen, fluorine. Okay, these are nothing but oxidizers. Whereas fuel means fuel. The other name of fuel is also known as a reducer. Okay, which is being reduced continuously during the reaction time. Whereas oxidizer, it will supply externally. Okay, therefore bipropellants are nothing but which consist of an oxidizer and reducer or a fuel, which will sustain an exothermic reaction when mixed and ignited. Okay, when mixed and ignited, these bipropellants are nothing but a composition which is having both the oxidizer and reducer, nothing but a fuel. Okay, um, so these bipropellants are frequently used in the rocket propulsion system. Now these bipropellants are very much popular in the rocket industry. Then based on the physical characteristic, the further classifications are solid, liquid, and hybrid. Now further, these solid propellants has been classified as double base and composite. What is double base now? Double base systems are nothing but a monopropellants, like nitrocellulose with diphenyl stabilizer and nitroglycerin explosives. Okay, certain explosive composition will be mixed. Therefore, it will obtain a double tone of energy to it. So this is called a double base propellants. Okay, which is nothing but a composition of nitrocellulose with diphenylamine stabilizer, and nitroglycerin explosive. Or may it sometimes it may contains non-explosive plasticizers also, such as diethyl phthalates. Okay, various phthalates will be available in order to give a non-explosive characteristics, because when these materials, propellant materials, are exploding means, therefore it will shatter the rocket. So therefore we need to deactivate that explosive characteristics. In order to deactivate that, we need to add certain types of plasticizers like diphenyl phthalate in certain composition. Okay, explosives are different from propellants, because propellants are the low energy chemicals, or low explosives, whereas the high explosives are nothing but main explosives. Okay, like try toluene RDX we defined, trinitrotoluene, TNT we define. Okay, these are the high explosives, whereas propellants are the low explosives. These propellants are nothing but a fuels which acts as a fuels, whereas explosives which are used for destruction purpose, like shattering any type of object, we have to use the explosive. For just burning and obtaining certain amount of heat or certain amount of energy from the particular matter, we need to use propellants. Okay, propellants and basic difference between explosives and propellants are nothing but this only. From the from the explosives, we don't extract any work. Okay, it is only used for the shattering purpose, it is only used for destruction purpose, whereas propellants we extract some work, some heat from it. Okay, thermodynamically we extract some mechanical work of the and we convert it to the heat formation, and correspondingly the we will extract some work from it, whereas explosives are used for exclusively for the destruction purpose or shattering purpose. So next one is the composite propellants. It is nothing but a mixture. It is also a mixture of finely ground oxidizers in a matrix of plastic. A matrix of plastic will be there, in which a finely ground oxidizers will be there in a form of resin. Okay, in a form of resin it will be arranged, the oxidizer and a fuel inside will be arranged. Sometimes it will also contain a elastomeric fuel materials also. Okay, this is nothing but a composite propellant. The examples for this type of composite materials are ammonium perchlorate. Okay, then synthetic rubber, SBR rubber, styrene butadiene rubber. You might have seen in the CT1 chemical technology one. Styrene butadiene rubber is also one type of energy system or a propellant system which comes under the category of composite system. Okay, then additives. Some of the additives like already I said, some of the explosive suppressants like plasticizers, it will contain in the composition of composite propellants. The next one is the liquid propellants. So in the among the liquid propellants, there are two further propellants, like we already defined here, monopropellant and bipropellant. In the liquid propellants also, there are two types of mono and bipropellants. Okay, they in the monopropellant liquid category, the examples of nitromethane. Nitromethane will be a liquid in the liquid form, is called a liquid propellant, and ethyl nitrate is also liquid propellant. And further, these liquid propellants are being classified into one monopropellant, whose examples of nitromethane and ethyl nitrate. And further, this has been classified into compound propellants. Compound propellants, whose examples we can define as ammonium nitrate and liquid ammonia, are the compound propellants, but they are largely used in the rocket propulsions, whereas the certain composition, the mixture of oxidizers and fuel is known as a hypergolic mixture. So now these liquid propellant systems has been divided into further two types, which are hypergolic and non-hypergolic system. So what is hypergolic system? A composition, particularly when preparing the propellant system, we will use oxidizer in order to aid in a combustion process, and at the same time fuel in order as a reducer in order to be consumed in the reaction. So the hypergolic mixture is nothing but a particular mixture which can be spontaneously ignited. Okay, naturally by its own means, it will get ignition source. We need not to supply some ignition source from the outside, whereas hypergolic mixtures are nothing but we need to supply the ignition source, like spark we have to give. For the non-hypergolic mixtures, we have to give some spark or some impact or some force we have to apply, whereas in a hypergolic mixture we need not to apply some ignition source. It will automatically burn, it will spontaneously burn. And next one is the hybrid propellants. Okay, these are nothing but usually a mixture of solid fuel and a liquid oxidizer. Okay, oxidizer usually in the liquid propellants, what will happen, the oxidizer will be in the form of liquid, and at the same time the fuel will be in the form of liquid, whereas in hybrid propellant the oxidizer will be in the form in the form of liquid, whereas fuel will be in the form of solid. Here you see in the burning of solid propellant, the air will act as air, nothing but a gas will act as an oxidizer. Okay, in the solid form, so the fuel will be in the solid form, whereas oxidizer will be in the gaseous form. In the liquid propellant, the liquid what we call fuel will be in the liquid form, whereas oxidizer will be in the gases or not gases, only liquid form. fuel and oxidizer both in the liquid form, in the liquid propellant, whereas in hybrid propellant only oxidizer is in the liquid form, whereas fuel will be in the solid form. Nothing but a hybrid propellant this is. Time is yeah. Any doubts regarding this one?
No, sir.
Okay, you understood everything. Wow. Boys,
Yes, sir.
nobody is there, boys. Tarun,
We
okay.
understood half of, sir.
Half off. Okay. Okay. Same once again. I will try to explain. Yeah. Shall I? Derivation. Can you understand the derivation?
Yes, sir.
Okay. Derivation is okay. Yeah. It is not a small formulas which we already seen in the school days. Nothing but the velocity definition, distance definition, acceleration definition. You just go through the derivation once again. So now the specific impulse. Specific impulse is nothing but a ratio of velocity of sound with respect to acceleration due to gravity. So specific impulse from the derivation we already derived, which is nothing but a ratio of force or a thrust with respect to change in that particular weight of a propellant per unit time. Okay, according to definition it is C by G, but according to our derivation it is F by dW by dt. So specific impulse, it is nothing but a effectiveness factor. Okay, we can, in the general sense, we can say it is nothing but a mileage of that particular rocket. How much distance it has to be traveled, at what speed it has to be traveled, it is dependent on only specific impulse, which is denoted by ISP. Okay, so it is as per definition, this is the definition. Specific impulse is the kg of thrust obtained by burning kg of propellant per second. This is this formula, and it is the ratio of velocity of acceleration velocity to acceleration due to gravity. This says this formula C by G, and nothing but a measure of effectiveness of a material as an energy source. Okay, nothing but an indication of mileage. So this dW by dt is always called as burning rate. Then chemical energy systems. Energy systems are classified into 5 types. The major energy systems classification is nothing but a 5 types of energy system. The first one among is the chemical energy system. The second one is the nuclear energy system or a nuclear fission system. Third one is the free radical system, and fourth one is the RPG system. Magnetohydrodynamic plasma system is the fifth one. So among these four energy systems, nuclear, free radical, arc jet, magnetohydrodynamic plasma, these are all underdeveloped and yet they are in the developmental stage, whereas chemical energy systems are advanced, somewhat advanced compared to this energy system. The disadvantage in this chemical energy system is it has a very low impulse, specific impulse, compared to other energy systems. Okay, so the main disadvantages in these four type of energy systems is they are in the at developmental stage, but this is developed stage. So always whatever the rocket we are seeing now, it is due to the chemical energy system only. So it will have an impulse of 200 to 500 seconds. Okay, impulse is nothing but whose units are seconds. Okay, you can see from here, F force we are measuring in kgf. So dw weight is measured in kg. So kg we can cancel, or not numerically. Numerically it's a different, so we will get some constant here in cancelling these units, but units will get only seconds. This t will go upside from the denominator at last denominator to the numerator it will go. So seconds will be the units of ISP, specific impulse. So nuclear fission energy system will have a specific impulse of 500 to 1500, whereas free radical system will have 1500 to 2000 seconds ISP. Arc jet will have 1000 to 5000. This has been arranged in the increasing order or the ascending order of the specific impulse. Okay, so as per your syllabus, this only the chemical energy systems has been given. So for the classification purpose, I am showing this 5 different energy systems. So next classification is classifying this chemical energy system. So chemical energy systems are classified into 2 types. The main 2 types are based on chemical reactant characteristics. The first one is based on chemical reactant characteristics, and second one is based on physical characteristics. So based on chemical reactant characteristics, these propellants, the chemical energy systems are divided into two types of propellants. So first one is the monopropellant and second one is the bipropellant. Then what is the monopropellant? Monopropellant is nothing but a single chemical compound or a homogeneous mixture of more than one compounds. Okay, but the necessary condition is it cannot be a heterogeneous mixture. Heterogeneous means you already know more than one phase. Okay, homogeneous is single phase composition system or a single chemical compound system is known as a monopropellant. Okay, already these all the energy systems are has a capability to burn indefinitely and to release energy from it. Okay, monopropellant is nothing but a single energy, single compound or a combination of a propellants with a homogeneous composition is nothing but a monopropellant. Whereas bipropellant is nothing but a which consists of a oxidizer together with a fuel. Fuel is usually called as a reducer. Okay, because it is reducing in the reaction time. For example, for initially if the 100 kg of fuel is there, then at the final stage of a rocket it will be zero or somewhat it will be less than that 100 kg, that 100 kg initially which has been started. So it is nothing but a fuel is nothing but a reducer. So bipropellant is nothing but a combination of a oxidizer and a fuel. Okay, which can sustain the exothermic reaction. Okay, this is the definition of bipropellants. Whereas the based on the physical characteristic, the energy systems are classified into three types. The first one is the solid, second one is the liquid, and third one is the hybrid. So solid propellants are further divided into two types: double base and composite solids. So double base solids or solid propellants are nothing but monopropellants such as nucleus, what we call nitrocellulose with diphenyl stabilizer and nitroglycerin explosives. Okay, some of the explosive composition together with nitrocellulose, which is also a explosive. This combination is known as a double base. In order to get a double energy, okay, double combustion energy, we will have a double base. Double base is nothing but a two types of fuel will be present. Two types of fuel, combination of two types of fuel will be present in a single propellant composition is known as a double base. Whereas composite is more than two types of fuels is present in the composition, which always have a finely grounded oxidizer mixtures fitted in a matrix of plasticizers and resins. In the form of resins, it will be fitted the fuel and oxidizers. It is known as a composite propellant, whose examples we can say the ammonium perchlorate or synthetic rubber SBR we usually called styrene butadiene rubber, which is a synthetic rubber. Okay, with some additives. Okay, which is a combination of composite propellant is nothing but a combination of a fuel, some synthetic rubbers and some plasticizers. Some additives we will add into it in order to get a better combustion characteristics. So next one is the liquid fuel. Liquid fuels are further classified into as classified in these chemical characteristics. These are also classified into monopropellant and bipropellant. So in the liquid form, the monopropellant are nothing but a homogeneous mixtures. It is also here as defined in these solid characteristics, solid monopropellant. This monopropellant same here also applicable. It is nothing but a homogeneous one. Okay, the examples for these are the nitrocellulose or nitromethane. Sorry, it's a nitromethane or ethyl nitrate. We can consider the examples of a monoliquid type of propellants. Okay, in this one other compound propellant is also there. We usually consider to a less extent we will consider liquid ammonium nitrate as a composite or compound propellant in the category of liquid. Okay, in this liquid there are bipropellants also. According to the previous definition, bipropellant is nothing but a combination of fuel and oxidizer. Similarly, here also in the liquid propellant, bipropellant is there, which is a combination of oxidizer and fuel. And further, this liquid propellant has been classified into two: hypergolic and non-hypergolic. The mixture, the liquid propellant mixture, will be prepared in such a way that it will contain the fuel plus oxidizer plus ignition source, which will be automatically get ignited when this oxidizer comes in contact with that fuel. It will just automatically spontaneously get ignited. Whereas in non-hypergolic mixture, non-hypergolic propellants, oxygen we need to supply a oxidizer fuel, and at the same time of ignition source also we have to supply, like ignition source, some spark or some impact we need to supply. Whereas in hyperbolic, we need not to supply any spark or ignition source. It will just ignited by its own source. Spontaneously, it will get ignited. The next one is based on the physical characteristics, a hybrid. In the hybrid propellant system, the oxidizer will be in a liquid form, whereas fuel will be in a solid form. Therefore, it is the heterogeneous mixture. Okay, two compositions or two reactants are present in different phases. One fuel is in solid phase and oxidizer is in the liquid phase. Therefore, we consider this as a hybrid propellant system. Okay, I think you understood this time. Is it okay now? Hello?
సార్
Is okay?
అర్థమైంది సార్
Okay. Then next class we will see the basic considerations. Yeah, time over. I will take attendance. Just send me the attendance. Just 2 minutes. Who is coming for the next hour? Ravi?
సార్ టైం
Time is 4 o'clock.
ఇదే
Next
లాస్ట్
hour.
అవర్ సార్ 4 అయింది సార్.
Oh, sorry. And attendance, just attendance. Next hour వస్తున్నారు అనుకున్నా నేను. ఓకే రవి, హలో.
Yes, sir.
రవి కొంచెం అటెండెన్స్ ఇచ్చేస్తావా నాకు? వాట్సాప్లో కొంచెం సెండ్ చేస్తాను.
Okay, sir.
ఓకే, థ్యాంక్ యూ. See you.